In this fourth video I will show how to write clients for CLAM using the Python application programming interface that is made available. In the previous videos we saw that we interacted with CLAM using the web browser. This was the web application, but of course CLAM is a real actual RESTful web service with which you can interact using automated clients. I'm going to show how to write such automated clients using Python. First we start an interactive Python session, because I will attempt to show this interactively. Then we of course need to start the CLAM service. We use the CLAM service we developed in previous videos. This is the frequency list creator. So we start it and it is running. Okay, and now we can start to interact with it interactively rather than through the browser. So in order to do this we first import the client application programming interface. Oh, there is a small error because my CLAM was not entirely up to date. If your CLAM is not up to date, just go to your CLAM directory. This is assuming you got it from GitHub, and issue a git pull request. Okay, now my CLAM is up to date again. We can retry. Okay, so import the client application programming interface and then import the data application programming interface. These you will need to communicate with the CLAM web service. The client takes all kinds of difficult work out of your hands by parsing the XML responses that you receive from the web service. If you would do this in any other language but Python, then you would have to write all that stuff yourself, and that would be harder and more time consuming. Okay, so now we start by creating a client. So we create a client instance that we connect to the URL that we started our web service on. So the server is available here, so we just copy this URL and we paste it here. Okay. Oh wait, I did something wrong. CLAM client is of course a vital part. This is the actual class. Okay, we have created the client, and we can use this client to communicate with the server. Let's for example obtain the list of projects that is available at the server. We do so using client.index, and we catch the response. Okay, we have caught the response, and now we can check in the response what projects are available. You see there is one test project, which you may recall we created in a previous video. Okay, now we want to create a new project of our own. We do this by telling the client to create a project named, how shall we call it, client test. Okay, the return code is true, so everything went well. We can, if we now want to check the list of projects, we have to invoke the client again. So we again call the index, and we see in the project list that there are now 2 projects. Okay, so the next step is to obtain the status of the project. So we can obtain the project by using the get method. This is one of the most frequently used methods in the client. So we get our client test project, and now in the response is encoded all kinds of data relevant to this project. The response is actually an instance of a CLAM data object, and it has all kinds of attributes. For example, an important attribute is status. The status can be 0, 1 or 2. If it is 0, the project is in the state in which it accepts parameters and input files. If it is 1, then the project is actually running, so the background application is actually running. And if it is 2, then the background application has completed and the results are available. I believe there is a method input files, which is a generator, so we use a list. At the moment we have no input files, as you see. It is an empty list. We are going to add an input file. Let's add the piece of Hamlet we had, and we do this using client.addInputFile. We first specify the project for which we add the input file. Client test is our project. Then we have to specify the input template for which we want to add a file. If you recall from the service configuration file, I still have it open here. You see that the input template was, for example, TOC input. This is where our tokenized text documents entered. So we specify that input template, and the next parameter is the file itself, of course. So we point to the file. I have it here. Okay, then we had some metadata parameters which we added in the third video. You can see here that we have a language choice. So let's make use of this and set the language to English for Hamlet to be or not to be. We can do this using a keyword argument where this part corresponds to the ID of the parameter, the metadata parameter. Okay? So this is it. We press enter and our file has been added. So we again query the project. I'll show, if you don't query the project and you list the input files again, the list is of course the same because it is still the old list we retrieved. So we have to retrieve first a new response. We do that as such. Then we list the input files and we see that there is indeed one input file instance. So I can show that this corresponds. Let's do it like this. I forgot one operator. Okay, this corresponds with the input file we just uploaded. So the upload was successful, and what we can do now is we can start the project. Starting the project is easy. We invoke the client again and we say start, and we have some parameters to specify here. We of course first specify the project. That's basically the only important parameter, but we have some global parameters in our service configuration file. Remember, we had the case sensitive option here, a choice parameter which could be set to yes or no. So let's say we want to set it to no. That we can again do using a keyword argument. Case sensitive is no. So now we start the project using the file we just uploaded and with one extra parameter. Okay, we start it, and then you once in a while should poll again for what the status of the project is. We see that the project is in status 2, and as I told, status 2 means that the project has finished. So that's precisely what we expected. So now we can take a look at the output present in the system, and we see here I believe 3 or 4, yeah, 3 instances of an output file. Let me visualize that in an easier fashion. Here you see the exact URLs of the output files that were created by the web service. So we have our frequency list for the input file, we have an overall frequency list, and we have an error log which is a CLAM default. Okay, now we want to download one of these files. Let's say the frequency list for Hamlet. Okay, this is the first option of the list, so I will grab it. Let me do it like this. Response output. Oh, wait, I first have to make. Oh no, it is a list already, so I can do it like this. Okay. So now I grabbed one output file. You see that this is the frequency list for Hamlet, and now we want to store it locally. So we invoke the copy method on this CLAM output file instance, and we save it wherever we want to save it. Temp test, for example. Okay, so now we have downloaded this file. We can verify this by going to an extra tab in our browser and inspecting the contents of the test file. And we see here indeed that we find the frequency list that we would have expected. So this almost concludes our demonstration. What you usually want to do if you communicate with, using an automated client is you want to delete your project after you're finished, because otherwise a whole bunch of projects will remain on the server. So the neat way is to create a new project and then delete it again when you're done. So our project was client test, and we will move it again. Oh, we have to invoke this on the client, of course, not on the output file instance. Okay, now the project is gone, and I demonstrated the most essential things of building a client for CLAM using the Python application programming interface. Oh, actually there's one thing I forgot and which I would still like to mention. The output files have certain properties that are very important and which are very useful to know, so I would like to add that still. Let's get the project state. The project is undeleted again, and we will get the response for our client test project. Right. We look at the output, we grab the first file again, and the properties I would like to show you are the metadata properties that are associated with this output file. We have to load the metadata using this method. Now the metadata is associated with the file, and we can query it. For example, remember that we set the language. This is how it can be retrieved. And remember that we set the encoding. A very important aspect is also the provenance data in the metadata, and the provenance data has an important property which you might want to use. This is the ID of the output template. So using this, you know exactly what output template generated this file, and this is often very useful because you want to know how the file came to be. Okay, so this concludes the presentation for real.